Hi, and welcome to another episode of the Kodiak Classroom. In this episode, we're going to go over the internals of a pressure gauge, as well as briefly go over how a pressure gauge works. Now, for simplicity reasons, I'm going to be doing this on a 4.5 inch dial gauge, but 1.5, 2 inch, 2.5 inch dial gauges all have the same type of internal construction. And I'll show you a smaller gauge towards the end of this as well, but obviously for video purposes, it's easier doing it on a bigger dial. So what are the parts? Well, first we're going to look at the socket connection. Okay, the socket and the connection are all one big piece of metal that's hollowed out is where your orifice is that connects to the media. The socket is then welded to the second part, which is the board-on tube. The board-on tube is this C-shaped metal you see. Now this gauge is calibrated for a 60 psi. The board-on tube metal and construction is designed specifically for the range. So for instance, on a 5,000 psi gauge, you might see a little bit of a thicker board-on tube, but ultimately the design is the same. The board-on tube and the socket are the only two pieces that will actually touch the media. So those are the pieces that are going to be made of brass, stainless steel, Monel or steel in some cases, all depending on how corrosive the media is or what you're trying to do. The most common being brass and stainless steel. Now the end of the board-on tube is connected to a link here. That link is then connected to a sector, which is a half circle gear. And I'll bring this a little bit closer to show you. I'm grinding it here. That's the gear. The sector is connected to a gear on an axis, which is hard to show in this video just due to some of the pieces here, but that's connected to an axis which is then connected to the pointer on the other side. So the idea behind a gauge has been around since the mid-1800s. What happens is as the media enters the orifice and then goes through the board-on tube, which is hollow, the pressure wants to make the board-on tube straighten out. That's connected to the link, which then moves the sector, which moves the gear, which moves the pointer. So as I move the board-on tube, you can see the link moving and the sector gear towards below my finger kind of going back and forth. That's moving the needle on the other side, which I'll show you here. And that's really all there is to it. Now, when picking a pressure gauge, it's important to know what your application is. So the other side is that there's obviously a lot of pieces on the inside of the gauge, which can be susceptible to vibration or pulsation in the line. So it's important to use liquid filling or snubbers or pulsation dampening movements on the inside, because what can happen is on a vibrating application, you get a lot of back and forth movement, okay, which is grinding the gears and moving the needle frequently back and forth. This ultimately will damage the gauge over time a lot quicker than normal usage. The other thing is pulsations. Pulsations are anything really a fast pressure exceeding the range of the gauge. So for instance, this is a 60 psi gauge, and if we had an application where all of a sudden you open up a valve and 300 psi hits the gauge, what's going to happen is it's going to exceed what the board-on tube is made for, and it's going to try to straighten it out. And if you exceed that, the board-on tube may not go back to its original C shape as far as it was before. So what can happen is you'll see often a gauge stuck here when there's really 0 psi in the line. So these are all things that can be prevented with, as I mentioned before, liquid filling, pulsation dampening, snubbers, things like that. For a real quick show you the 2.5 inch dial, or this is actually a 2 inch dial. And just to show you, it's the same amount of parts, just a lot smaller, which makes these a little bit more sensitive to some of your more rugged, bigger dial gauges. And you still have your socket here, board-on tube, your sector, and then the gear connected to the pointer on the other end. So as I move the board-on tube, the pointer moves. And that's really all there is to it. If you have any questions, please feel free to email us at kodiak@kodiakcontrols.com or visit us at kodiakcontrols.com. Thanks, and we'll see you next time.